Alright, making a video response to a couple of points raised by Hythloday in a relatively favorable video, polite and in some ways complimentary, but you can't take it too seriously because it's Hythloday, so you know there'll be a catch to any positive statement usually, so we'll just wait and see. I mean, he looked like a good prospect early on, and then he turned really sour, and then he, now he's looking like a prospect again for the first one to concede. But we'll see. There's only, I think, 10 people in the contest. $3,000 contest. 10 people. Yeah, the internet. It's just such bullshit. Especially now. I mean, there's just no, there's no, the popularity engine just closes so many doors. Anyway, so I guess we'll play his statement where so he says, yes, I'm liking this and I'm liking that, I'm liking it's mechanical, I'm liking, blah blah blah, but then he gets to this.
The deficit in a deficit that DraftScience has in its model.
So, I mean, that's okay, you can say it that way, but it's just when you perceive, so you should qualify it as something you don't get, or you can't see the handle on the pot, or whatever that I claim exists. But I think as your earlier concessions, you're realizing, oh, I really wasn't seeing the metaphor. Like, eventually I think you're going to see the school of fish metaphor and get that the fish universe is the only universe. The school of fish is an illusion. There's only one universe. It's the small universe. And all discussions about anything else going on always has to be in the context of what are the little bits doing. Because they're the only bits that are doing anything really.
That I don't understand that whether he sees as no need for it.
Yes, well, I'll comment on that, even though you haven't got to the subject yet. I didn't say there was no, I haven't said any such thing. I've clearly addressed the subject over and over again. And I think, again, I've given you plenty of metaphors. The basketball metaphor, I mean, the player is moving much slower than the ball is moving, kind of stuff. The velocities are very different, like 100-fold different.
Right. Orthodox physics would have it that there are two mechanisms in which clocks break that time.
I don't know, I thought I had this sped up. Yeah, I do a little bit. Yes, and you could have just said, you've already used these words to me. I understand the concepts. There's general relativity and then there's special relativity. And it doesn't matter which one is doing which. One is recognizing velocity as just a thing, independent of gravity. And the other one is accounting for the acceleration caused by gravity as a form of velocity. And those would be the distinctions, I would argue. There's nothing special about gravity to the cause of time dilation except for the component that would be the acceleration caused by the gravity. And the acceleration is being added as a velocity. And so the total velocity of something in gravity would be stated to be higher than just its orbital velocity, for example. You have to add the acceleration. It's being accelerated towards the sun. So you have to add the 10 meters per second to the motion because it's a real acceleration, and therefore it's a real, it's something, the little bits, it's part of their dance. They have to dance both velocities, the acceleration due to gravity and then they have to dance the velocity that will be their trajectory. Now their velocity is in a straight vector and it gets bent into a curved line, and that's the byproduct, but that byproduct has in it two motions. So the real velocity is this and this. The real velocity isn't this. Okay, that's the point. Is what's really happening is this motion is doubled. That's the real component. This is an illusion. This is the part we see. This is the only part we see. Is the thing pushed this way and it pushed that, like any kind of mechanism. You could think it hits a wall and it hits another wall and it pushes the walls. The point is we're just seeing the walls move. Let's just say the thing moving the walls is invisible. So all we see is the wall motion. And we don't realize that for that wall motion to happen, something had to go all the way across and all the way back, which means it actually traveled twice the distance, and we're only seeing this distance. So I've used the Aliasing word, something people sort of understand from the internet, the jagged line thing that happens around fonts, or the jagged line thing around images when you have too few a pixel. And that's a demonstration that your real velocity is how much you're bouncing, like the basketball. Okay, so the player is moving, the earth is moving, that's the player, okay, bouncing the ball. But inside the earth, the ball's bouncing in the gravity. So the more gravity you're in, the faster you're bouncing, which means the more distance you're really traveling, which means your actual velocity, the actual velocity that the little bits have to dance, the actual dance that has to be performed, is much more complicated than what you're seeing. There's much more to it. So there's all this bouncing happening inside the earth. And that's the real velocity of the little bits in the real universe. So the real universe is doing a lot more work than what we perceive as it's the earth moving around the sun. No, it's a huge giant school of fish, and for the fish to move this way, they had to bounce around a whole lot and argue with each other to get the job done. And that took a lot of time to argue with each other, figure out, add this velocity to this velocity to this velocity for this velocity. They had to do all that calculating, and that's the real time consumed, and that's the real amount of distraction their velocity is causing their function.
Apparently distorted. One is movement, but there's a second one to do with gravity and distant place in a gravity field.
So he's saying one has to do with movement, but that's just the velocity idea. Velocity is the cause of it. That's Einstein's notion. That's sensible. He's blaming velocity. And then he extends that to understanding that gravity is a source of velocity, of movement. So whether you call it acceleration or velocity, the point is an acceleration is a velocity, and even if you decelerate, shortly after you accelerate, it doesn't matter. That's a real velocity, and it's always real movement. The whole process is movement, and it will break the clock just as much as the actual velocity.
And orthodox physics makes a calculation to arrive at a prediction based upon these two characteristics.
Well, again, that in a sense I think is being deceptive. Let's understand the one theory. If you just went based on the apparent velocity, okay, then the satellite's going much faster than we are, and you'd have to adjust the clocks on the satellite because they're the ones more affected. That would be the one relativity theory. The one that's the dominant one, the one that accounts for more of the motion, is again the basketball. That's where the big gain in velocity is in the Aliasing. So gravity, the acceleration by gravity, is the bigger component. That's the bigger hunk of the velocity. So us on the Earth are actually the ones going too fast, and it's the satellites going 20,000 miles an hour that are going too slow. That's the irony of GPS, is, in a sense. So the two theories have different conclusions, in the race, comparing the basketball player to the basketball. Okay, then how to equate the velocity numbers. How many dots go across the floor by the basketball, comparing that to the footsteps of the player or something. I don't know how you would do the metaphor. But the point is that the one relativity theory says, again, exactly the opposite of what the other one says. They have opposite conclusions about who's going faster. And when you add the two up, though, the amount that the basketball component is so much faster, it dominates the equation.
That being the case, DraftScience can't claim to have exactly the same mathematical implications.
So again, I have no obligation to change the mathematical calculations at all, because I think I've correctly cited the cause for whatever's in the formula. The formula just has acceleration and velocities in it. I'm not disputing either the velocities or the accelerations. So the mathematical formulas shouldn't in any way be different from what I'm stating. The real effect of gravity is extra motion. It's movement. Right now, your cells do move, your atoms, your particles, and they actually hit the ground hard. Okay, they hit it with real pressure. You leave real indentations in the earth when you walk. Some more than others. Real ones. So your acceleration is real. Your movement is real. It's just happening on this tiny, tiny scale that you can't see. But the pounds per square inch is large. Okay, it's a big amount of pressure. And the push back is just as real. The earth saying you're adding pressure, I'm pressurizing back, is just as real. So you are, in fact, bouncing on the surface of the earth, and the speed of that bounce is happening so fast that we can't see it. You don't look blurry to me, okay, in a sense, because the bounce has such a tiny period that you don't see it. It's a speed of light kind of bounce. The frame rate is so fast that there's no way to perceive the bounce. But if you could slow it down, you might be able to see it. Well, it doesn't matter whether you can see it or not. You can understand the reason for its existence. That obviously pressure is transferred from the top of me to my feet and into the ground. And then the ground exerts pressure on my feet right back up through me. And that's how it works. The little bits are in motion.
It's orthodox science. But that isn't the purpose of this video. But it's certainly...
I know, but see, throwing little lines like that, well, DraftScience hasn't accounted for, he hasn't addressed properly or completely, he hasn't given a proper answer to, well, I'm just throwing that out there. Not a tactic I really like. So anyway.
Relevant to this because I'm going to speak even more favorably.
Right, so he just basically concedes that the dancing metaphor is a good metaphor. And like I said, eventually he might come around to understanding the school of fish metaphor is a very good metaphor too. The school is defined by what goes into it. And we're defined by what energy goes into us. We possess it. We capture a component of it. Again, this is such an important concept. And I didn't even have the clarity to speak of it this way. But you really do have to understand that you could throw something into a little bucket on wheels, and the bucket would catch the thing without any friction, and so it could catch it in a loop, let's say a frictionless loop. So you could throw it and it could get caught in a frictionless loop, or bouncing back and forth in a frictionless trap. And you wouldn't realize the same kind of momentum that if you throw it and it's hard and it gets stuck in the bucket and it stops moving. Well, then you know the bucket's going to really move, because it's going to take up all the energy that the thing had, because you're going to stop it from moving. But if it could still do what it was doing before, photons do that, they keep moving. Well, the photon's circular motion would add up to nothing. Okay, so there would be no net movement, because it's obviously consuming in each, it's doing all 360 degrees, so there's no possibility of a movement. And the only thing you really captured was that first initial bit of inertia in one direction. And that's what you've essentially captured and you're holding. So you won't give that back until you let it go, let it fly out of the loop. And then you'll give back that one little tiny bit of force, in the sense that you'll get a little tiny jolt. You know, the letting it go will cost you a little tiny bit of motion. But that's all we're capturing. When we capture a photon, we're not capturing the photon's whole energy. We're just capturing its the little, whatever its inertia or its momentum was at the instant we trapped it. And that's the only part we keep. And we can keep it for 10 million years. That's what an atom is. It's full of a bunch of energy that's been trapped. And that's, you know, motion that's been trapped. But that's the thing about it. If you can trap it for free, that's what the nuclear universe can do. It can trap it for free, no friction. The atoms don't get tired. You know, millions of year half-life kind of things for most atoms. Trillion years. They don't run out. The grease, the frictionless grease they're using works very well. However you want to metaphor it. They've trapped energy. And now, because they can trap it for free, you know, you just need space. Whatever space you have, you can fill the space full of traps. Then obviously you can release a tremendous amount all at once, you know, because you can just collect it for free. And you can release it for free, technically, so, you know, except you explode. But anyway, so it's, like I said, the getting this down to the little grain bits and just understanding they're the only things doing anything. The only motion in the universe is the stuff moving the speed of light. Everything else is essentially just being dragged along by those, made out of those fish, and essentially. But that component of momentum is the momentum that makes everything move. And for atoms, the only part of that momentum they're keeping is the little bit of motion that was the first, the direction that it was moving when it got trapped. That's the pit they keep. And how to say that some other way, that's the part that they realize as their own motion. That's the part that defines where they're going. The bit is which way was it going when I caught it. So he's going to mention spin, which is another interesting subject. I mean, spin is obviously kind of an ether concept, right? I mean, the spin only can really mean something if you have some swirly stuff that gets dragged along with the spin. If everything's spinning in empty space, so to speak, like electrons and stuff, certainly photons could hit an electron and come out at a bizarre angle, but they'd also have to come out with more momentum, which doesn't make any sense. So there has to be some reason why there's no momentum exchange. So that gets into another kinematic argument about how do you transfer energy between things that are spinning. And technically, as I pointed out 7 years ago in the very beginning of this whole thing, and I pointed out how all the interactions are at the same speed. So really you're not transferring momentum between force and force. So whenever you're interacting with something that could possibly be spinning, which would be an attribute of your internal function moving the speed of light, the generator of the spin would still have to be a force moving the speed of light. So whatever hits it is always going to be speed of light on speed of light. There's no momentum difference, so that fixes the momentum problem that spin would create. But my only argument against spin is it's an unnecessary complication. Two, when we see spin in the big world, like the planet spinning, you can sort of get the idea that that's really a consequence of gravity, you know, because as something's moving, as I'm pointing out, it's a leasing, it's being pulled, it's going to tend to pull more in the direction of its velocity, and that might be how spin is acquired. One reason. The internal bits are going to tend to turn in the front more than they'll turn towards it from the back. So it's one of those, the laws of probability say it's more probable that the front part's going to go towards the Earth because of its going away from the Earth in its vector, you know, so it's going to turn like a magnet would turn, and so it's going to start turning. But let's just say there was some mechanism that would allow electrons and all these other little parts to have spin. I think the consequence of that would be even more diffraction, you know, even more bizarre kinds of interactions. I don't think you could have like two slit patterns created by spin, because, you know, it just wouldn't, you know, different angles, everything would be flying off at different angles. I just don't think you could have anything that would be regular enough to cause the patterns, and there would be a lot more scattering kind of effects. So I don't think spin is necessary to the story. I think it's an added complication. I think where we see it, we're seeing it in a much more complex world where things are in atmospheres and where things are interacting with each other because of other forces, big things, and that little things aren't going to by nature spin. So I don't think it's a viable reality. But I'm not discounting it's possible. Certainly. It's possible this is one of the properties that these little bits have. But I think it's for certain that photons don't have spin, because then they would really be quite irregular, and they appear to be quite regular.
DraftScience's paradigm, if not his model. See, his paradigm is my paradigm. That is, cling on to reality for dear life.
Yeah, so he rephrases that because he doesn't want to sound like you're just doing it for emotional reasons. But yeah, the logic just dictates. Why would I believe in gremlins and UFOs? Just because somebody can make up a story, why should I believe the story? And the rational story is to say everything I observe has very reliable properties and very boring ones, frankly. Nothing's doing anything very, like, surprise! Did I surprise you? You know, the pen doesn't surprise me by, you know, pooping gold. You know, there's no, you know, so every bit of evidence kind of tends towards this very strict mechanical laws and insanely reliable. Like, you know, maybe the universe makes errors, but I'm saying the density of the errors is so tiny, you just don't see it. I mean, photons do literally travel billions of light years, which is gazillions, zillions of miles, and they don't lose a beat. You know, the tape doesn't degrade. The music is Memorex perfect. I mean, nothing gets, you know, and so there's every appearance that that's the reality. There's no reason to think, oh, when the universe starts getting small, it gets all wacky. No, there's no reason to think so. No good reason. So, yeah, maybe I've said all I need to. What does that say? So, so I covered the GRSR thing. Small universe is the only universe. More interactions. So that's all you're really counting. So as I'm trying to point out, with the combining an acceleration this way with a velocity this way means the school of fish has to do a lot more interactions. And it's the interactions that are a distraction from the interactions that would be the atom's orbits, the energy cycle of the atom. So you're disrupting how the atom vibrates and how it goes through any process of deterioration it might go through. So we already know there's atoms that have half-lives of 10 minutes. You know, that they're fundamentally unstable, and that after 15 hours all of the material will have converted into another material that is isotopically different. So somebody's giving me shots about this difference between isotopes and ions. I just frankly couldn't be bothered. To me, it's all the same thing. You're just talking about an imbalance in the magnetic configuration, and you have a stable configuration, and then when you take one of the magnets out of the configuration, it kind of destabilizes it. So you can understand that's all of these atoms that are radioactive just means that they have a component that every 700 vibrations it creates a quirk, where it vibrates too far. It does what mercury does. It processes a little. It screws up. The calculation doesn't come out to an even number, and so it causes a hiccup in the function. And you get 17 hiccups, and by the 17th hiccup, that's the biggest hiccup, and it breaks a piece off of it or something. So you can kind of understand the instability argument. And so obviously if most of the clocks we're using to do time dilation experiments are atomic clocks, they're clocks that are dependent on the speed of this deterioration, it makes perfect sense that whatever cycles that cause the atom to finally fall apart, those cycles will be slowed down by the fact that you're moving the object, which means you're throwing more interactions in and saying, no, you have to do these 10 other things before you can get to your 7th cycle, or then your 8th cycle. You're slowing down the mechanism by creating other mechanisms that consume the time the other mechanism was using. I mean, if you're taking a cup of water and scooping it into from one bucket to another bucket, and then somebody says, well, no, you have to stop and count to 10. You can just understand, well, I'm not going to scoop as much water in the same amount of time, obviously. So anyway, he's conceding a grasp of that concept anyway, and I think it can be understood as a real mechanical thing. And I think you can understand that although they say gravity is causing the time dilation, I think you can understand that I think what Einstein was really saying is movement is, velocity is. And you can understand that an added interaction, something to consume, the mechanism has to work more. So all you have to do is concede that velocity is working inside the mechanism. The space shuttle's full of the velocity, the big fire put into it, and that if it has some other velocity, acceleration, that clearly that's more interactions, more stuff going in, having to be interpreted by the school of fish. Yeah, it changes what the school of fish will do, because it's consuming time to do these added interactions. So I think he's getting the concept. The fact that he thinks there's some conflict between their math and this diagram, I don't think there's any conflict at all. So I think that's enough of a video. I mean, it's not like he doesn't say anything important here, but he's just agreeing with some of these, what I've paraphrased to be the basic fact that these metaphors are useful and insightful in terms of seeing what's the universe is really doing when something is doing something, understanding that there's more to the doing than what we see. When you see the Earth going in a round orbit around the sun, it's not the truth. It's not how the Earth gets from point A to point B. It's traveling some perfect curve. The fish are a lot more chaotic than that, than the Earth's motion would make apparent. just as if you looked at a basketball player from a distance, it's just a blob moving across the court. When the truth is the feet are going faster than the basketball player, the shoes, and clearly the ball is going a lot faster than the player. Yeah, that's a really good metaphor. I don't think anybody can pick that apart. Alright, so I think that's enough. Call it a video. And such. Till next time.